Welcome to another episode from the Ed Ed. Today I'd like to show you my 3D printer enclosure that I've come up with here. It's based on a Ikea Lack table. And you know, these little tables, they're quite popular in the 3D printer community. And there's quite a few variations of them on Thingiverse. And of course I'll post my version on my account for you folks in case you're interested in 3D printing any of these parts out for your project. The Lack tables are only like $15 a piece, and so what I wound up doing is buying two of them, and I'm not using the legs for the second Lack table, and I might, attach those at some point and put it on the floor. My printer is a Wanhao I3, and its power supply and control electronics are integrated into the lower part of the printer, and my initial concern of putting this printer in this enclosure was that the electronics might get too hot. And so I have come up with these little ductworks that will allow air flowing up through the holes in this tabletop, this bottom, I guess you should say, of this enclosure, to allow air to flow through the cabinet of the 3D printer and then out through a squirrel cage centrifugal air fan that's on the back here that's also ducts into the cabinet. And my particular printer is kind of unique in that when I first got it, its power supply was a bit on the weak side. It would brown out and ruin the print, so I wound up getting a slightly larger power supply that physically forced me to lower the bottom plate of the enclosure down by about a ½ inch in order to fit it in. So my printer has about a ½ inch gap on the side that I think normally most of the printers wouldn't have. And so by happenstance, it's kind of an advantageous thing that allows me an air gap that these ducts can then mate up to and allow the air then to be pumped through the chassis of this 3D printer and then out. And then also for airflow control, I have a bypass duct control on the centrifugal fan and also an air vent on the top that you can control. So between the two, I should be able to control the temperature of the 3D printer's electronics and the print volume here and allow it to build up a little bit if I want to for maybe the more challenging 3D printing plastics. In my instance, I tend to just stick with PLA plastic, and even PLA plastic, after being exposed to it for a few hours in the study, will start to cause me to have a bit of a tight chest and start coughing. So I would definitely recommend, at the very minimum, coming up with some solution to avoid breathing 3D printing plastic fumes. My particular design, which, like I said, there's quite a few variations out there, quite a few clever solutions. I use a shim design on each end of the legs, and they serve multiple functions. In my instance, I have some recycled magnets from my ultrasonic toothbrushes. It's really quite handy for latching the door, along with some fender washers. And then these guys also act as little guide points for the panels, which can slide out easily. And on the hinge side, the hinges are integrated into the shims, and the whole top can come off, and there's some alignment pins that allow you to guide it back into place. So I think it's a fairly easily serviceable design where you can take the panels off if you want in order to get at the printer, if you want to get around the backside and do anything, or you can take the whole top off. And obviously, a lot of people aren't going to have an i3, and they aren't going to have an i3 with an unusual gap in the plate and so forth. And so my guess is the majority of people are probably not going to go with my little unusual cooling ductwork thing here, but you might give it a whirl if you happen to have a printer that you're concerned about cooling, or at least some concept of it. At the very minimum, even if you didn't do the ductwork, you could still use the fan basically as is without the little bypass and just have this bypass up here. And I think that solution would work actually quite well. So I'll go through my build process of this guy and show you the various features, and feel free to use any all bits and pieces of this design for your particular project. And hope you enjoy this little build of mine. I certainly enjoyed it. It was a lot of fun. Okay, so I thought maybe before I went too much into the assembly, physical assembly, I might actually show a little bit in FreeCAD, the program that I use to produce this design. And if you're not familiar with FreeCAD, it's available for Windows, Apple, and Linux. Of course, I have a bias for Linux, and it's free. It's all totally open source, and I also, for my work, I use Inventor, AutoCAD Inventor, and Autodesk. And I must say, for the, considering this is purely a free open source program, it's gotten really good. It's getting really close to the commercial programs as far as I'm concerned for usefulness, especially for, hobby stuff. So I highly recommend it. I'm using A2 Plus assembly module for assembling this guy. You'll notice that in the assembly I've fixed all of the parts into place with them basically being locked, with only the exception of the door and the hinges and so forth. So if you want to move anything around, just simply unlock the position here, and then you can move them around and so forth, at least based on the various rules on how the assembly is moved. So I guess probably the thing is, it's a Ikea Lack table with 2 tops, and I'm only using one set of legs. I suppose if you want to put this on the floor, you can put the other set of legs on and put it on the floor. The little shims that are used to raise the height a little bit for the Wanhao I3 printer, they do a number of different functions, and I called them top and bottom, and it probably went through a little extra work unnecessarily, because about the only thing that's different is this little chamfer here. I was thinking at the time it might help a little bit in putting the sheets of plastic in, but I don't think it really made any difference. Those little things that wasn't unnecessary. So you have 4 of those located on the ends here, and a whole bunch of brackets. I think I labeled the brackets as horizontal. Of course, a lot of them are vertical, and you can kind of see the relations where they're sitting. Obviously, you can add more if you want. This is the utility bracket here. It has extra slots in here for wires. Obviously, you can modify yours to add more slots if you need more. Plenty of room there for that. The hinge side, there's a top and bottom hinge, and once again, they screw to the legs and the top of the table, so that you can just take the whole top table off. There's alignment pins hidden underneath these lower parts here. I guess I can show that to you real quick. Visibility off. So if I turn that bottom off here, you can see, it's kind of hard to navigate. See these alignment pins here? They basically nest inside the lower shim feet, if you want to call them that. They screw to the top of the table, the bottom as it were, and provide alignment so that table can just go, tabletop can go right back on. Let's see here, turn that back on again. Okay, so I'd recommend using 3-inch long drywall screws and screwing the shim into the leg with just 2 of them, and use the screw that is one of the screws going through the pivot point for the hinges, and that'll lock them in nicely, or hold them in place so that the whole top can come off with the door with the hinges nicely. The other thing would be these shims here that have some magnets. In my instance, I just happen to have some ultrasonic toothbrush replacement toothbrushes, and so I have all these nice magnets that have been accumulating all this time, and I pop those off and double side tape those in place. Obviously, you can put an annual disc magnet or whatever magnet you want in there that might fit. And I haven't bothered to depict it here, but there's some fender washers that I've taped on the outside of the door with just some shipping tape, and that snaps that door closed very nicely. Let's see here. The Wanhao I3 printer, I didn't bother to model too far, but it's enough for alignment, fits, and checks, and so forth. And like I was mentioning earlier in the intro, I have a whole bunch of holes, a series of holes drilled in this base table to let air flow from underneath the table through these holes, through these ductworks, into the printer housing, and then that gets then ducted out. Let's see with that window open, it wants to highlight the window, doesn't it? It gets pumped out through this ductwork that's in the back here, and then out through this kind of elaborate hose fitting attachment. Obviously, you could come up with something different if you want. The one thing that does require a bit of skill, I guess, would be this particular window here. You have to kind of cut out that little shape here for that part, for the window to fit in past this guy here. It was a little bit of trial and cut and fit and sort of thing. We'll use some pieces of tape and then kind of slide the window into place and slowly cut it out with a saber saw or a reciprocating saw. You'll notice that in the back here there is a bypass vent control, and also, and let's see here, move that over here, another bypass vent control. These bypass vents are rotated 180 degrees to get the full opening. I used once again, didn't bother to depict here, a screw long enough with a nut and some washers and a spring, and so you can pull up on this little knob here a little bit to get it to clear these little indexing points, and adjust it to whatever point, let go of it, and it'll just stay put there. The spring kind of helps out on that. At the top here is a couple little funnels with a little hole just barely big enough for the 3D printing filament to go through. And it was one of those points I was kind of concerned whether or not it would work too well. And it seems to work pretty good. I've not had any troubles with a 3D printing filament feeding through there. You can see I got these ductworks. They're labeled front left, front right, and rear. Let's see if I can see that rear one. Yeah, it's over there. And yeah, as you can see it right there, the window. I had to hand drill some holes to clear some screws that are on the frame of the Wanhao, and so I kind of guessed as to where those holes are at. So if you go to print yours, you might find that I didn't guess those holes right. Later on when I show the actual drilling and assembly part, I'll have to go through and detail a little bit on how you position this guy in. But basically, the positioning of the fan here largely dictates the left-right position of the printer. It's sitting flush with this side here. Then this guy kind of mounts to that with a couple screws onto the side here. Now front back can be adjusted a bit as to where you really want it to be. I biased my printer a bit towards the front, but I made certain that the table, which I didn't once again picked, can travel all the way forward without hitting the door, getting access better. And then these vents here are then screwed on based on how this the printer is sitting, along with how this adapter fan intake part is sitting here. So air flows into the machine through here and then out through this duct here with its little bypass. And so hopefully that's clear. I guess I could show a few of the parts and go into how they're printed real quick. Maybe I'll show this one real quick. So this guy, he fits over that centrifugal squirrel fan, and I printed him standing up basically like this with a brim. And this way I got away with not having to use any supports or anything like that. It seems a bit of an awkward way of doing it, but it actually worked pretty well. So if I can orientate something to avoid doing any supports or anything like that, I will do it. And this one printed actually pretty decently going that way. Okay, this guy is pretty elaborate. I printed him sitting basically like this. So this surface here is on the build table of the printer, and it all printed out pretty nicely. I didn't have any drooping or any troubles at all. And this surface here is the surface that mounts to the side of the table here, just 2 screws, and then this kind of slides over the fan. And then this little feature here is for clamping the power wire for the fan itself, so you can then plug the speed controller through the side here. Once again, you'll have to cut your Lexan plastic window to fit this guy, and I fit it so that the plastic window could still have a little bit of an overlap in this gap here. It sat flush on that surface, and I'm just trying to keep this in the window, and kind of slid on this surface here, and tried to obviously keep that as tight as possible. I think it prints out pretty nice. Obviously, you can come up with your own version if you want a different orientation. And let's see here, what else? Rubber feet. I bought a set of rubber feet at Ace Hardware, and oddly enough, they had like 5 or 6 different sizes, from relatively small to large, packs of 4. They're all exactly the same price, so I bought the biggest ones. And I just positioned them out a bit from the corners and screwed those in. And let's see here, what else is there to really say? The original Wanhao, in this case, printing filament reel bracket I just mounted on top of this guy. That worked fine. And I think that's kind of it. Is there anything else really to let you folks know about in the CAD model here? I think that's pretty good. Well, I guess I'll show you the I'll show you those one of those unit hinge side. Okay, so this is one of the this is the, I believe this is the lower one. Yeah, this will be this lower hinge shim. You can see it has this bushing, as it were, that the actual moving hinge that mounts to the door window is mounted to, and you can see the slot for the plastic, and you see various chamfers here for your drywall screws or wood screws you want to use. And I use just 2 drywall screws, one going through this hole and this hole to mount to the leg. The leg would be on this side. If you wanted to, you could mount their top permanently in place if you wanted to by screwing through these 2 holes, I suppose. But there's kind of a conundrum as to how to get screws going this way and this way, so maybe you can't do that. The alignment pin goes obviously through here, that lines this table to this surface here. Hopefully I'm not getting too redundant in my explanations. I think it's kind of basically it. So I guess on to actually just showing you a bit in the shop of drilling and screwing and so forth, and kind of let you know what's going on with that. Okay, so now it's on to the working in the workshop here. I've attached the alignment pins to the base plate, as it were, of this machine, and it's kind of on to figuring out how to do the alignment of the exhaust fan. And the exhaust fan, being it ducts out the side, will basically control the position left or right of the 3D printer. And the rubber feet are really inexpensive feet from Ace Hardware. I think it was like $5 for a pack, and they're all priced the same, whether they were large feet or small feet. And the nice advantage to having this foot here, beyond the fact that it doesn't mar your tabletop and so forth, is it supplies an air gap, because all the air is going to be drawn in from underneath the base plate, base table here, up through the ductwork, assuming that your folks are interested in doing the crazy ductwork system I'm going to do here. So the next thing is kind of test fitting this guy. And the other biggest problem is my machine is kind of unique in that I had to add a larger power supply. So I had to put these gaps and the plate to lower it down to have the power supply fit in. And initially I was going to use these 3D printed little standoffs here, and I found out that on the side where the power supply was closest to the cabinet, I really didn't have the space, so I wound up using simple standoffs. And here you can see how the ductworks have their own little arches and so forth for fitting it in. The bottom of the machine has a bunch of louver work for intake, but it's really blocked by the power supply. And so there's kind of a debate whether or not I wanted to put yet more ductwork for that cooling fan. But I think there's going to be so much air drawn in and through the control cabinet that it's not really going to be a problem. That fan will probably not wind up drawing a whole lot of air from the warmer chamber into the machine. Here I'm doing the initial location of the squirrel cage fan using the small little mounting flange screw holes. Later on I'll be using longer screws for mounting the adapter ductwork on top of the fan. And then my unique little exhaust port here is mounted on the side. Obviously, once again, if you folks choose to use any of my elements, just feel free to modify them or do whatever you want with them. This guy just holds on with just 2 screws mounted on the side. And it's just, once again, a matter of match mark and drill the screws. Sometimes I like to pilot this stuff just directly in place without even having to mark with a pencil or felt tip pin, and you get nice, quick, easy alignments. It's just easier to go with the through-hole screw that's actually going to be the right size. And just a few drywall screws later, this guy's ready to go. And then the air intake ductwork goes on top, and I've yet to add, in this case, the little control bypass plate here, but you get the idea. 3-inch long drywall screws work quite well for a lot of this project. Here's kind of a layout of how the ductworks ultimately go in without the 3D printer in place. And here it was a lot of marking initially to find those locations and drill the mounting holes, and then locate a nice even points where I'm going to have a whole bunch of the vent holes. And after initial pilot drilling, I just used a classic wood drill bit to drill through all these guys. And it's lots and lots and lots of holes drillings later. Okay, so lots and lots of drill holes later, we got all these vent holes. Luckily, the Ikea top is mostly hollow. It's just a couple thin pieces of formica, basically, and some honeycomb material that holds it in place together, sandwiching the 2 sheets. And the question kind of was in my mind as to what sequence to actually mount all of the ductwork, and I ultimately wound up kind of doing it as I'm portraying here. I had the front left one in place, and then I put in the exhaust duct over the fan, and then I did the last two at the end there. And it was kind of debatable whether or not I should have done the fan ductwork first like this or last, because when I ultimately got to the other side, I realized, oh, once you get the 3D printer in place, you really can't get these the last screws that are underneath the ductwork in place and slide the 3D printer in place, because it's such a snug fit. So it might have been better, would have been, to maybe put maybe the fan top in last. I'm not sure. Anyhow, you know, it's obviously overdone to use so many screws, so they're not going to go flying off. So really, just the outer ones were more than sufficient. And then it's off to getting the bypass vent drilled in the top of the enclosure. And here I'm using a large circular saw hole cutter. In my original CAD, I kind of grafted in a bunch of series of holes using the wood drill I used earlier, and you could probably just do a series of holes just like I did for the ductwork if you don't happen to have a large saw hole cutter like this. It just made life so much easier. And obviously you do get a little bit better conductance, although there's more than enough airflow in this design. Really not a problem at all. Most of the time the bypass will be probably, you'll find, needs to be mostly closed anyways. And then once you pop this disc off, it's a really great view of the honeycomb spacer material. It's just cardboard. It's amazing how well engineered Ikea is on trying to dial in something that's, you know, functional but as absolutely cheap as possible. It definitely is one of those things you have to wonder how much weight one of these little tables can actually handle, because it looks substantial until you pick it up and realize how lightweight they are, because they're mostly just hollow and just mostly just a couple pieces of Formica, you know, very thin ply of wood material, and mostly just cardboard. Here's another cutout for the center hole for the 3D filament feed-through cones, and I just used, of course, another saw hole cutter. And then from there, it's basically you cut out your pieces of plastic as far as cutouts for the exhaust duct, and position your little clips and so forth however you want. I went to a plastics shop and had the pieces of plastic cut to dimension, and initially I had some odd little dimensions that I was going to go with, and just at the last moment I decided to round off to more traditional even English fractions and so forth. So if you can, you know, for probably not a whole lot more money, just maybe go to a plastic shop, have them cut them to dimension. I find cutting plexiglass kind of challenging, but I did manage to get the little notch cut out for the exhaust and for the utility slots. Okay, so I think that's kind of the build process in a nutshell. Little minor things to maybe take into account. I used 3-inch long drywall screws, and I had to countersink these screw holes a little bit in order to make them work. You can obviously use 4-inch long screws. Like I say, I don't seriously expect people to use the ductwork idea like I did here, but if you feel inclined to do so, if you happen to have a Wanhao or some similar concept, it may not be really necessary. Most of the airflow, I think, is still going to go through the electronics enclosure. It's going to be at a slightly lower pressure than the rest of the build chamber. So as far as airflow and having this big slot where the belt drive goes through, I don't think that's really an issue. And as it is, you know, I can put my hand in there and feel a nice general warmth at about 1/4 of the fan speed. Perhaps I'll do a little follow-up video on with some accessories like better lighting instead of this little snake neck light I got shining in there, and I put in a thermometer system and so forth. All kinds of little accessories that could be done that are fun on these sort of homebrew 3D printing projects. Anyhow, I think that's a wrap. Thank you for watching this and letting me share my project with you. And tune in for next project. Thank you.